So far this morning, we have worked upon the Casey and its units worksheet. The answers are available on Google Classroom for you. And then we looked at the second worksheet entitled Standard Level KC Calculations. Then we are now going to very briefly look at dropping everything on the floor and making as much noise in the background as possible. We're then going to look at another type of equilibrium constant another type of constant, it's not an equilibrium constant, called Q. And then we're going to introduce Le Chatelier's principle. And then don't forget, the test is on Friday. So here we go. This is a constant called Q. And the only difference between Q and Kc is that Q is at non-equilibrium concentrations. Okay, that's the question that has come up so far on this. What's the difference? The answer is that Q is non-equilibrium concentrations, Kc equilibrium concentrations. If you have to write an expression for them, they are exactly the same. Instead of writing those Kc equals, you write Q equals. Simples. So now on to Le Chatelier's principle. Now Chatelier's principle allows us to predict what happens when we change the conditions of an equilibrium. And like with rate of reaction, we're going to look at a variety of different changes. So we're going to look at changing concentration of both reactants and products, increase or decrease in temperature, changing pressure, which only affects obviously reactions involving gases, and the addition of the catalyst. And we're going to learn how to use the Chatelier's principle to predict what happens to the equilibrium. So here is Le Chatelier's principle, and it allows us, as I said, to predict what's going to happen when we change the conditions at an equilibrium. You can see this is typical of pictures of all scientists. No matter what or when they made their law or whatever, the pictures of them published are not when they created the law, but later, when they were much older. Don't know why that's the case, but it is. Le Chatelier is very famous. If you look at a map of Paris, there is a Le Chatelier Rue, I think it is, and I've got a funny feeling on the metro there's a Le Chatelier station as well. So it's very famous in France. Shame none of you are from France, because that would be a nice bit of internationalism for the IB covered. So, his principle says a system at equilibrium will react to oppose any change imposed upon it. So if you do one thing to an equilibrium, it will try and do the opposite. So if you increase the temperature, it will try and decrease the temperature. If you increase the pressure, it will try and decrease the pressure. And what we're going to look at after the test, okay, don't forget, test on Friday, Senya Prom and Ping An. I will be emailing it to you. After we've done the test, then we will actually be looking at, in detail, his principle. But that's enough for today.